Hey everybody, how's it going? Today we are going to be working on a MacBook. This is a MacBook that doesn't turn on. It's also a MacBook whose airbags have been deployed. We are going to figure out what's going on with this MacBook, fix the airbags that have been deployed, and see if we can make it work again. Looks like we got 31 people watching on Twitch. Not bad. Not horrible. And we got 16 people watching on YouTube. Beautiful. Wow. This is very interesting that Twitch is actually beating out YouTube for viewers at this point, even though I barely use Twitch and I've been using YouTube almost every day for the past 9 years. Nothing like platform loyalty here. Anyway, so let's get some work done. So we have a MacBook here that's not turning on, and as you can see, the battery is kind of deployed there. So first thing I'm going to do is I'm going to unplug the battery. We know we have to replace that thing anyway, but the main reason I'm unplugging it is because I don't want it to disturb any of my troubleshooting process. So we are going to unscrew the battery, because the battery here is actually, the power connector is not a connector that just pops in, it's a connector that actually screws in. Unplug the battery, and then we're going to see how many amps this board is taking. I want to see how many amps the board takes by itself because it helps me in my diagnosis. It's going to give me an idea of what's going on. Every time I have a problem with a MacBook, what I do is, once I've solved the problem, is I take note in my brain, and now also on repair.wiki, of how much amperage it was taking, and then I link that to the problem. So here, move to Virginia Beach, you know you want to. That would probably piss off Chris B in the Discord quite a bit. It may be worth it for trolling purposes, but okay, stream is working. So we got 20 volts. That means that our CD3215s are working. These are the chipsets that are responsible for the USB-C charger communicating with the machine and the computer saying, "Hi, I am a MacBook. I'm not a GoPro or a phone. I want 20 volts. I am not satisfied with 5 or 9 volts." So that's working. And those chips, as I've mentioned in recent videos on charging in the CD3215 and USB-C charging on MacBooks, they require a power rail called PP3V3_G3 hot. So the fact that we're getting 20 volts on the charger means that that is present. Now it's taking 18 milliamps. Obviously 18 milliamps is not enough for anything to actually work or function. So I'm going to take the board out of the case, and then we're going to try and see if anything looks funny. We're going to measure around our power rails, and we're going to see if we can figure out how to make this beautiful MacBook work again. This is, I believe, a 00281, Paul Daniels. Surprised that you can't see that from where you're sitting. I feel kind of good today. I feel sad but good at the same time. There's something that's been plaguing me for the past year and a half that I have not been able to get over. And it's been causing me stress and aggravation and trouble. And I didn't notice. I really thought it was something that's been bothering me for a year, but it's actually been bothering me for about 14 years. And I didn't really notice it, how deep-rooted it was and ingrained into my life until I look back and I realized that it's not a new problem. It's actually an old one that just keeps resurfacing. And I've taken the measures that I think are necessary to correct it, and I'm quite excited. I'm not at the point where I am enough of a... where I'm... what's the word I'm looking for here? Yeah, I'm still too much of a coward at the moment to discuss it publicly. But we'll see. Maybe a year or two down the line when I can laugh at it, I'll share more. But I'm kind of happy today. Kind of wonder if it winds up changing my personality as well. One way to find out. So let's take all the screws out of this. Let's get all the screws out of this. Why are black Capri Suns in this MacBook? That is not a Capri Sun. That is a lithium-ion battery. It's a very safe lithium-ion battery because it's made by Apple. That's how you know that it's not going to do things like expand in the bottom of your case. Lots of WAP things going on in Australia. What's WAP? I'm noticing that the younger generation likes to use acronyms a lot. That's how I know I'm old, when I just don't understand what most people are saying anymore. Oh, Mighty Soul, I'm excited about that machine. I'm waiting for Driver Pack to finish downloading, and I'm going to start setting it up. I installed Windows on it, but it doesn't see the Wi-Fi hardware, so I downloaded Driver Pack just to get all the drivers on it, and I'm excited to start using that framework, but I'm also fixing a board. I've been postponing a lot of health-related stuff until these past 2 months. I've never felt better. Yeah, I'm excited. I may wind up regretting some of the decisions that I made, but I think I'll be healthier for them. I think I'll be better able to live my life, so I'm excited. What with all the acronyms for components you mentioned? I don't use acronyms for my components. PP-bus is not an acronym, it's a word. I have not looked into Windows 11. I'm not particularly convinced that Windows 11 offers enough to be worth upgrading. I'm honestly not even convinced that Windows 10 offers enough over Windows 7 to be worth upgrading. I think in the end, the better anti-aliased, whatever the fuck you say. Thingy that makes things less jagged that they fucked up on the PlayStation 2. UAP is an acronym. Yeah, but I don't know what it is. And instead of telling me what you meant, you used an acronym, which I don't understand that trend of using acronyms instead of just explaining shit in plain English. But when people do it, I tend to just say the acronym as a word and then pretend it means whatever the hell makes sense in that moment. There's no character limit to the point where you can't just type out what that means. I don't know what the PP-bus stands for. I just assume that whoever makes these imagines himself peeing on the board every night. I have no confirmation for what the PP-bus actually is. Maybe it's the long yellow school bus that takes Apple employees to their workplace. No way to know. Yes. PP-bus. Okay, I'm going to take all of these things and I'm going to put them in this little baggie. Everything goes in the baggie. Like that. Beautiful. Okay. We take the board out of the computer. We set the computer aside. We take a look at the motherboard. We take a look at the other side of the motherboard. Does anything look out of place to you all? Anything at all? What do you see on the screen? I see a MacBook board that's just trying to be a MacBook, but it's unable to be a MacBook for some reason. So it's our job to figure out why it's not able to be a MacBook. Now, when you have a no-power board, one of the things it says in my starting document, and you can take a look at my starting document in the description down below, it's free for anybody to read and explains all different types of things that are going to help you on your MacBook board repair journey, is to take a look at the power rails. One of them may be missing. I will let the terrible fire out, Mr. Terrible Fire. Also, it's really good to see you here 8 years later. Just the fact that there are people that were watching this in 2013 that are still watching in 2021, that means something. Thank you. Now, as I said, these rails are not listed in the order that you expect them to show up on the machine. If, for instance, pp3v3 underscore g3 hot, I expect this to show up before ppbus g3 hot. Now, because we have a 20 volt reading on the charger, that means that this little chip over here, this USB-C controller hub, USB-C controller, this USB-C port controller needs to be turning on. And for this to turn on, its voltage in over here, which is 3.3 volts, pp3v3 underscore g3 hot, this needs to be present. So I don't have to measure that rail. I can actually take that off of my list of rails that I have to measure. What I'm going to measure instead is my ppbus g3 hot. And remember that all of these rails are like a pyramid. You need your G3 hots, then your S5, then S4, then S3, then SO. Different power rails are going to be on at different times. So, for instance, in your home, you may not have power going on to your television when you're not home, but you would have power going to your home security cameras when you're not home. But when you are home, you may have power going to your television. That's just a really, really base level example. But so all of these little suffixes here, like G3 hot, S4, SO, what they mean are this power rail is going to be present when the computer is in this state. So the computer exists, G3 hot, that power rail is present. Like the battery power, that's always going to be present as long as the machine is there and it exists. S5, when the computer's off. S4, when the computer is hibernating. Something like the keyboard, because you hit a keyboard button to get the computer out of hibernate. You may click the trackpad to get a MacBook out of hibernate, and some MacBooks have the trackpad powered by their S4 rail. An S3 rail, a rail that's on when the computer is sleeping, or in the sleep mode, the suspend mode, which would be, let's say, the RAM, because when you put your computer in sleep mode, it saves everything to the RAM, which means the RAM still needs to be powered, even if the CPU is not. SO is going to be your screen's backlight, or let's say your CPU. When your computer is sleeping, your CPU is not being powered, even if your RAM is. So we need the rails that are on the bottom to be present before the rails on the top are present. Now, pp3v3 underscore g3 hot is most certainly going to be present. We don't need to check for that. But we do need to check for rails like ppbus g3 hot all along the ppbus. So let's see if we can get on our ppbus and drive. So we're going to turn the board over to where I can see my ppbus. And this nice big fuse over here, we're going to go on big fuse F7000 or F7001, and we are going to measure that and see if it shows up on the screen. Now, whether it shows up on the screen depends on whether Paul Daniels' software wants to work today. Let's see. Are we feeling lucky? Okay. There we go. Paul Daniels' software is working today. Zero volts. Now, when a rail is not present, there are multiple things that can cause that power rail to not be present. The first is that it's not being asked to be created. So if you have a chip that has an enable pin, perhaps there's nothing going to its enable pin. Perhaps another chip is not turning on that chip by sending a signal to its enable pin. The enable pin of many chipsets is going to kind of be like a light switch in a room. You flip the light switch on for the lights to turn on. You flip the light switch off for the lights to turn off. You cannot blame your electricity for not working. You cannot blame the light bulb fixture or the light bulb being dead if you have not turned the light on. Second, the chip that makes that rail could be dead. Your light bulb could be dead. Third, there could be a short circuit to ground somewhere, so that even if you do have your enable and the chip is doing its job, it's being shorted to ground somewhere. So my light bulb could be good. I could switch it on, but there could be a short to ground in the fixture of the circuit somewhere that causes that good light bulb and that good light switch that is flipped on to not work. So what I'm going to do is I'm going to measure and see if I have a short to ground on PP-Bus G3 hot by switching my meter over to ohms mode and then unplugging the power from the board, because when you're doing resistance measurements, you never want to do resistance measurements with power going through the board, because the way this works is it's going to send something from here to here, and it wants to see how much comes out on the other end. So if there's already power going through the board in that rail, it's going to screw up the measurements. So don't make ohm measurements with power going through a circuit. It'll screw you up. And as you can see, we have 0.7 ohms to ground, which means that there is something that is shorting our main power rail to ground. Now, there are many ways that you could try and figure this out. You could just look at the board to try to figure out if anything looks blown up. You could inject power into it and do what I call the Owie Test, where I go over the board like this and go, oh, once I figure out what is hot. Or you could use a thermal camera, which I don't use because it A, requires getting up, and B, the software that it comes with is highly finicky and always messes with my computer's internet, which causes my stream to go down. And I think it's some weird Chinese software that I can't read the terms and conditions of because it's not even in the proper format for me to be able to read anything. So I prefer to not use it. But the reason that whatever it is that's shorted to ground is going to get hot is because electricity always kind of it wants to be even. Like, electricity doesn't like being 18 volts, minus 18 volts, 10 volts, even 5 volts. It doesn't like that. It wants to be 0. And the way it gets to 0 is by going to ground. So ground is reference. It's also 0. So if there's 5 volts and it sees a path to ground, it's going to go, I want to go to ground, I want to go to ground. It's kind of like kids that want to go home from school on June 26th, which is the last day of school in the New York City public school system when I was a kid. Everybody wanted to go home all the time. They didn't want to be at school. They would cut, they would do everything they could to get out of school. And that's exactly what electricity does. It doesn't want to be 5 volts. It wants to be 0. Now, if you give, if one of these components shorts to ground on the board, instead of a small amount going to ground, everything's going to try to go to ground as fast as it can through that particular component. And if all the electricity coming from this charger, all the electricity tries to go through one component to get the ground, that thing is going to get really, really hot. Because electricity is energy. Energy is going to manifest itself as heat when going through something. So what I would like to do is I would like to take a nice little look at the board and see if there's anything on it that looks obviously blown before I even bother doing something like injecting voltage into the board to try and figure out what's wrong with it. So let's see if we can go through this board together, you and I, and see if we see anything that's obviously blown up or bad on the rail of PP-Bus G3 hot. Now, the board has a little bit of a dusty look to it, but the dusty look itself is not going to be, in and of itself, the problem. So, Sonny, this is an 820-00281, and I hope to be able to find the problem soon because I would like to get myself some lunch. I am hungry. And I am going to get myself some lunch the moment that I finish this, or order something. I can't wait. So I really got to find out what the short to ground is, because if I don't find the short to ground, then I won't get to eat. I kind of wonder if that's the same. I shouldn't give myself the working conditions that the people who probably manufacture these things have. That's kind of mean. But then again, why should I get better working conditions than the people that actually work on this stuff, you know? Okay, here we go. This is not going to be the cause of our problem, but it is something I'm going to take note of. What do you guys see over there? What do you see? What I see is a solder ball. It's no good. No good. It's a solder ball. That usually means there was heat in that area, or that thing could have blown up, but I don't think that that's going to be our issue, because I don't believe that PP-Bus G3 hot goes through there. Alright, so we're just going to look around a little bit. We're just browsing. Think of it like we're browsing a grocery store, looking through the aisles, seeing if there's anything that we want at that particular grocery store. And then just imagine calmly walking to the grocery store. And then there comes Bill Burr. And Bill Burr looks at you and says, "Well, apparently I work at a grocery store. Ah, gee, let me grab my apron." I love Bill Burr. I also love the skit that he does about going to the grocery store and the self-checkout. That thing's hysterical. I am genuinely... I lied about the board, by the way. This is an 820-00928. My bad. But it's almost the same layout. In many ways, it's almost the same layout. So it's, for me, it's no big deal. Like, I still know that those two fuses are for PP Bus G3 Hot. Okay. So, no, I don't see anything that looks obvious. Again, you do have... Okay, here we go. We have another solder ball. That doesn't necessarily mean that's my problem. That could just be Apple's shitty manufacturing. That's just how you... This is some shit manufacturing right here. Okay, we're at the point where I am going to inject 1 volt into the board and see what gets hot. Now, I'm going to remove the heatsink before I do that. The reason I'm removing the heatsink is because it may very well be the CPU that gets hot. Now, the way a buck converter works, a buck converter is going to take a higher voltage, like 12 volts, and turn it into, let's say, 1 volt for the CPU. It does that by slicing it up. So you're going to have a slice of 12 and then a bunch of nothing. A small slice of 12 and then a bunch of nothing. A small slice of 12 and then a bunch of nothing. And that is then going to kind of average out into 1 when it goes through a buck converter circuit. And if you take a look at the documents that I include in the description of this video, the Introduction to Board Repair, you will find a beginner's guide that goes over how a buck converter works. And this is an important thing to understand when doing short detection on a device that has multiple different power rails. Because if you miss out on this particular piece on a device that has different power rails, you may wind up sending too much voltage to something that shouldn't get it. So let's go over just the absolute basics of a buck converter here before I explain to you why it is that I don't want to inject more than 1 volt in. So this is basically a buck converter. And again, this document is a document that is linked down below. It is my little crappy teaching document. This is going to take 18 volts and turn it into 12. So you start with a high voltage, like 8. You switch it, 8, bunch of 0. A little bit of 8, a bunch of 0. And at the end of the buck converter, you get a nice smoothed out 0.8 volts or 1. And it looks like this at every step of the way. So you have 8 volts up here, pulses of 8 volts over here because this transistor is turning on and off and on and off. And once it goes through the inductor and has caps to ground on the other end, it looks like a nice, happy 0.8 or 1 volt or something like that. You get the idea. Now, what if this set of transistors is shorted? What if this transistor or this transistor is stuck, right? Well, if this transistor is stuck, let's say this transistor is shorted to ground, it could mess with this one. And if you mess with this one, let's say this one's not pulsing anymore. Let's say it's just sending the straight 8 volts through. Now, if this is the problem, and I decide this is a 12 volt power rail, I'm just going to shove 12 volts in there, what if my short circuit is here? And what if this one's also broken, so I wind up sending up a straight 8 volts right into my CPU rather than pulses of it? So what I do is, what is the lowest voltage in this device where PP Bus G3 Hot is being used in a buck converter to create it? Is that 2 volts, 5 volts, 3 volts, 1.7 volts, 1.2 volts? And I inject that in. Just in case it's one of those MOSFETs that's powering the CPU or the memory or the NAND that is at fault, I don't want to send in so much power that if this MOSFET is at fault, that it is going to wind up sending a straight up 8 volts through everything. So when you're doing short detection, it's best to start out with the voltage that is the lowest voltage necessary or the lowest voltage of any power rail in the machine, whichever one is a lower amount. So I usually tend to start out with like 0.5 volts and then slowly bring it up to 1. And If what is getting warm is the CPU, then I know it was the CPU MOSFETs that have failed. And if that's the case, nice try, little screw. You're not running away from me, mofo. That little screw tried to get away. And if it is one of the CPU MOSFETs, then I replace it. But I won't have to worry about the fact that I then had 12 volts go through my CPU. Many people will see that's a 5-volt power rail, so I'm going to try to short detect it with 5 volts. And if a MOSFET has failed somewhere that turns 5 volts into 1 volt, and that's the failure, then you may wind up doing your short test and actually sending 5 volts into a circuit that's meant for 1 volt and overloading everything on that line. So I short detect with the minimum amount of voltage necessary to do the job. And you don't get thermal cam because I don't feel like finding it and hooking it up and dealing with my stream not working when I'm done with it because of an Ethernet problem. It's too much of a pain in the ass. I also got to see where my Ethernet cable is in here. I don't know. Nice try. I will use my fingers, my face, and then if all else fails, skin from other regions to try and find the short. We are committed to finding the short. Okay, do that. Pick the board up and the heatsink should come off because I know that Apple's thermal paste is definitely not the type that just dries out over time, right? Of course not. Yeah, about that. You will actually benefit greatly from replacing the thermal paste on these machines. Okay, so now what I'm going to do is I'm going to turn on my power supply. I'm going to turn on the power supply software. The power supply software is software that is independent of Paul Daniels. The multimeter software is software that requires Paul Daniels. And we're going to see what happens. Okay, so I'm going to set the voltage in my power supply software to 1 volt. That's a fairly low figure. I'm going to attach the ground of the power supply to the ground of the board. And then I am going to solder the positive of the power supply to the positive of PP-Bus G3 hot. There is no positive PP-Bus G3 hot. There's just the PP-Bus G3 hot, pretty much. So I'm going to take this. Solder you on. Excuse me. Owie Test, Owie Test. Yes, the Owie Test. Power supply software. SMA. Why are you SMA? What's wrong with my power supply software? It allows you to see what shows up on the screen. It allows you to see how much amperage it's using. Don't you get snarky about my power supply software. I love my power supply software. Okay, so we have this plugged in. And now we are going to hit the output. And we're going to send 1 volt in. And at 1 volt, it is using 3 amps. So this is going to be a really easy to detect short, because a short that is taking 3 watts, again, 1 volt times 3 amps, it's actually kind of burning itself out now. Crap. Come back. Should be easy to feel. So we are going to move around the board. And we are going to do what's called the Owie test. We are going to try and figure out what it is that is broken. And I believe I have found it right here. This is actually something that did not require the use of my power supply. This required the use of my eyes and my brain, which today I did not have, unfortunately. Luckily, I remembered to not have the power supply be at a high voltage. So I'm not concerned at all about the fact that I missed this very obvious area. Now, when you take a look over here, what do you see? This is really not something that even needed the power supply, to be honest with you. So A, if you take a look at the chip, you'll note that there is this, it's kind of sticking up over here. See that? And B, there is liquid on the side. Now, this customer said they never got liquid on their computer, which is obviously an outright dastardly lie. So what I'm going to do is I'm going to remove this MOSFET, and then we are going to see if it changes the condition. Now, let's take a look at what this MOSFET does. I'm going to load the proper schematic for this board because I opened up the improper one by accident, but they're almost the same. A1707 versus this one, it's almost the same thing. So this is an 820-00928. So wait, this is, yeah, 820-00928. So we're going to load this on the screen, and schematic and board view. We're going to take a look at what this chip does. So what is this chip? This is U7220. U7220 is going to be what acts as the transistors in this buck converter. So in the other one, I had what looked like 2 transistors in the buck converter. Here you don't have 2 transistors, you just have this. So you have PP bus over here, PP bus G3 hot, that's going to be your 12 volts. That's going to come in over here. And this is then going to take that and it's going to switch it. That's what SW stands for over here. SW stands for switch. It's going to switch on and off and on and off and on and off and send pulses of 12 volts through this inductor. Now, on the other side of this inductor is going to be where it is smoothed. And that's going to become PPVCC SO CPU. And PPVCC SO CPU, when we look on the board view, is going to have a lot of capacitors that are going to smooth it out over here. You can see there's no shortage of capacitors to ground over here to ensure that it is smooth. And this is very similar to what I displayed in my buck converter over here, even if it is a different implementation of it. Again, instead of having 2 transistors over here switching, one to ground and between here, and one between the high power source and ground, I mean, one between the high voltage and output and the other between output and ground, they just simplified it by having one chip over there. But it's the same general principle. Now, if I did my short detection by sending 8 volts to this, or 12 volts because it's a 12 volt rail, and this is malfunctioning, I could have sent 12 volts to my CPU, and I don't want to do that. Sending 1 volt through, well, my CPU should be fine with 1 volt, so there I should not have an issue. Now, there is always the possibility that while this machine was malfunctioning, that 12 volts got sent to the CPU. That does happen. Now, the PV Bus G3 hot power supply is pretty smart. If it detects that there's a short to ground, typically what it does is it turns itself off if it senses that there's overload. And you can figure out how it does that if you want to watch any of my other videos I've done on this channel explaining what current sensing is. The PV Bus G3 hot creation circuit is a current sensing circuit, and the current sensing circuit is going to notice this is asking for way too much power. This is, no. We're not creating anything for you. My power supply doesn't care. My power supply will just keep pumping out power all day. But this is going to limit it. And what our hope is that PP Bus G3 Hot's power supply was able to limit itself quickly enough once that transistor failed so that 12 volts did not go to the CPU. The reason that you'll notice that Paul or Chris or Dan or Anel or I will start to cry when we see that there's corrosion on the edge of the board when the CPU MOSFETs are on the edge of the board is because when you see corrosion on the CPU MOSFET, you have to pray at that point that the board itself that limited the voltage going to the CPU before that transistor shorted. Because if that was sending a straight up 12 volts into the CPU, your CPU is dead. Back in the Core 2 Duo days, this didn't really matter as much. A Core 2 Duo could take a 12 volts to the face just fine. These newer CPUs, as the transistors and as the architecture has gotten smaller and smaller and smaller, they can't take 12 volts to the face the way a Core 2 Duo can. And with each passing year, this becomes more and more of an issue where you're going to have machines that are less likely to have a good CPU just because of the smaller architecture. Again, a 12-volt punch to the face is going to be different for something with a much larger architecture than something with a much smaller architecture. That's not any fault of the manufacturer. That is just, that's just the progress of technology. So what we're going to do here is we're going to find a donor board, and we are going to replace that and ensure that there is no short present after we replace it, and then from there, call it. Let's see if it works. Further, another thing that you may notice here that gives us a hint at the fact that this is our bad chip, even if you didn't see the corrosion, and this is important, are those solder balls. Do you see those solder balls over there? Those solder balls by the chip do indicate that you have a problem. So when I see those solder balls over there, what that tells me is that something bad happened here, and I should focus on what happened there because it's bad. It's not all the time. Sometimes that can just be shitty Apple manufacturing, of which there is no shortage of. But that is, in this case, those solder balls are going to be the cause of my problem. So what I'm going to do before I remove that transistor, the first thing I'm going to do is cover up my my GPU and my CPU with the heatsink, just so that while I'm heating this area, I'm not heating them up too much, and I'm going to really try and focus my heat only on this little chip over here, and I'm going to remove it. Then we're going to get a donor. We're going to solder the donor chip in and pray at that point that our CPU is not dead. If the CPU is dead at that point, we will give this machine a Paul, where he will happily take CPUs off of an endless, never-ending queue of donor boards that may or may not work, to find one that works and spend 45 minutes each soldering them on until one of them actually works. And to think that he gave up his career in automotive for this. So, let's do it. Now, usually I want to preheat the board before I remove the chip because I don't want to mess up the chip. But here is the opposite. I don't want to preheat every area near the CPU. And also, I don't care if I mess up this chip because that chip's dead anyway. So, I'm going to clean off that area. Okay, we are now at the point where we are ready to locate a donor chip. So I'm going to go to my stack of donor boards and see if I can find myself some of these. I'll be right back, right after this commercial break and message from our sponsors. Sponsors, take it away. Do we have any sponsors? Any? Even one? Who am I kidding? I could use some sponsors. I really got to learn how to shill. I got to learn how to shill. There are people that started doing YouTube after I started doing YouTube that already became millionaires, and they don't even teach you anything. They just shill. Shilling is powerful. Shilling is a powerful component of economic well-being. Are you serious? The donor board that I just grabbed has liquid damage on it. Okay. That is... No. Okay, those are the sets that are... those are not the ones that came from China with everything ripped off of them. This one is. Here we go. I'll take it. You know what? No, not you. So finding a donor board that you like is kind of like finding an avocado that you like or fruit that you like at the store. Even if you go to a fancy schmancy grocery store like Whole Foods or Trader Joe's, you don't just buy whatever they have out there for you. That doesn't really make sense. What you want to do is you want to squeeze around a little bit. You know, you want to inspect your fruit, squeeze it, make sure that it's not too soft or too hard or the wrong color or corroded. And the same is true with your chipsets on your donor boards. You're not always going to be able to get the chips that I show you here from Mouser or Digi or Newark, because a lot of the times Apple will tell the manufacturer of the chip, I don't know if this is true in this case, but it is in many other cases, to not sell the chip to anybody else. And that's really, really harmful to the independent repair industry, to customers, and to the, I imagine, the just general advancing of society. And because the way that a lot of the people that start companies like Apple wind up learning how to do all this is by messing around in a garage, and you kind of take that away when you do this. But yeah, we don't really get our stuff. It's not like, you know, our chips are just bought from a nice little spool. Sometimes the only way that we're able to get access to what it is we need to do our job is, you know, bumbling around and, you know, squeezing around the boards and figuring out which ones are fresh for picking that week. So I am going to take this chip, I'm going to take it off of my donor, and I'm going to put it on here. But we're not done yet. We are not done yet. There is still more work to do, and I am going to show you what else we are going to do to make it as likely as humanly possible that this works after we are done. Why shill when you can teach us how to fix our Apple-branded sponges? Okay, Apple-branded sponges is actually a really funny way to put this. Apple-branded sponges. I should sell sponges with an Apple logo on them. I wonder how well that would go over. That would probably get me into serious shit for copyright or trademark infringement or something, but it would be funny enough to be worth it. Okay, now I had a little bit too much solder on the top, but that's fine. I'm gonna clean it off with my my micro pencil here. Now it's gonna be difficult to use the micro pencil because this area, since it's delivering power to the CPU, which uses more power than anything in the system, it's gonna have a lot high thermal mass. All the traces and all this stuff over here is gonna have very high thermal mass. Frustrating, but I have not been very successful with incentivizing or motivating Dan or Paul to do videos, so unfortunately you're stuck with me and my shitty motor control. Okay. So now we're going to take it a step further here. We're going to take it a step further. I want to see where this PWM signal is coming from as well. And you know what I'm going to do? I'm going to replace the controller chip, not just this. So let's say this died. Let's say this thing died, right? Let's say that it died and it just sent unfiltered 12 volts everywhere. Well, what if it kills the controller? If it kills this chip, which is the controller chip, then that means that the controller chip may be dead, which means that the controller chip is then going to kill the new chip that I just placed on this board. And that's not any good. So let's just go over what can happen when a buck converter fails. Let's say one of these transistors dies and shorts, right? This transistor dies and it shorts. Now it's sending 12 volts everywhere. Well, it's sending 12 volts to this and to that. So I replace this, but even after I replace this, now this is dead. So now because this is dead because it got 12 volts, now this chip is telling this to turn on all the time. So I replace this, but now this working chip is now being told to stay on all the time and then dies, and then I replace this, thinking this is bad, but now I just killed this. You understand how this could be a royal pain in the ass? So what I like to do, to diminish the likelihood that I ever turn this machine on or put power through it again while it's in a state to deliver more power to the CPU than what's supposed to go to the CPU, to diminish the chances of this CPU being dead when we try this again, I am not just going to replace that one component in the buck converter over here. This is not going to be the only thing that I replace. We are going to replace both chips. We are not just going to replace this one over here, U7220. We are also going to replace the chip that controls it, which is U7100. We're going to replace them as a pair. Because if you don't replace them as a pair, you risk that one of them is dead. Now, you may ask, is there a foolproof way to tell if one of those is dead? And when the donor boards are as cheap as they are, though I'd rather just replace it, to be honest with you. It saves my time. Now, granted, you may be able to try interesting metrics by measuring a known good board, measuring diode pin to ground on each pin. This does not guarantee anything, but it's a good likelihood of being able to tell if it's dead, and compare that to a known good board. But you must consider the cost of time. Time has a cost to it. And Also, if this chip was stressed, even if it's okay, what if it fails down the line? What if it fails down the line and this customer winds up having 12 volts sent to his CPU? He is not going to be very happy. Now, maybe it works just long enough to function, but that's not good enough. I don't want to have a 30-day warranty where we say F you on day 32. I want to be able to give this back to the customer and have them be confident that they have something that is going to last for the long haul. Because your customers are not going to support right to repair if everything you give back to them lasts for 30 days and then craps out on them while they're doing a presentation at work, or while they're in the middle of an important meeting, or while they're in the middle of doing their PhD thesis. That's not good. So it's a very small cost in both time and money to replace both parts of the circuit. Also, sanity. Sanity is a big part of it as well, because if you are replacing one chip and that one chip was killed by another chip that then is going to kill it again, and then you replace the other chip and now the first chip is now dead because it killed it, and you get in this little loop that will drive you insane. Maybe because you'd have gray hairs by the time you're in your early 30s, or be 50% gray. And be an insane old person that chills flux all day. So, we are going to do is replace everything from the beginning and see what happens before we power this back on again. We don't want to have any more situations you have to worry about this. Also, by the way, PP-Bus G3 Hot is the rail that was shorted to ground. Now, the battery is expanding. Can anybody here tell me what the direct link is between the battery expanding and PP-Bus G3 Hot being shorted to ground? For extra credit. This is an extra credit question, and I'm curious if any of you will figure it out. Let's see what you got. The battery is PP-Bus G3 Hot. The battery is PP-Bus G3 Hot. So, if there was a direct short to grounds on PP-Bus G3 Hot, the battery might have been asked to deliver more power than it's supposed to for a prolonged period of time, which then may have caused it to become mad and explode. Fuck. Thank you, Shy. How is the battery asked to change more? The battery is asked to give more because the battery now has a 0.7 ohm path to ground, rather than its standard path to ground, which is not 0.7 ohms. So when you walk up to the battery and you say, "Hi, I'm a 12 kilo ohm load," you're not asking the battery for much. When you walk up to the battery and say, "Hey, motherfucker, I am a 0.7 ohm load," the battery is then going to go, "Ah!" and blow up. It's also going to be mad at you. And the way it tells you that it's mad at you what it does to tell you that how mad it is at you is it goes full airbag on you. I know, but you're being a pedantic prick, and I'm just pointing it out to you that you're being a pedantic prick. You're being a pedantic prick. Okay, now we get the replacement. I definitely didn't miss the point. You're being a pedantic asshole, and I'm just reminding you of that. Lewis has more shaky hands than an OPEC meeting. It's not the OPEC meeting that causes people to have shaky hands. It's the people who invest in oil futures that are shaky at that point. The OPEC people are going to make money hand over fist one way or the other. Okay. All right. Go around there. Go back here. Shit. I just slid it over. Shaky hand, shaky hand. No worries. You make a mistake. You fixed a mistake. Shaky hand, shaky hand. And it's a good thing I'm not a surgeon. I'd imagine in another life, I would be a surgeon getting sued for malpractice on a regular basis. Luckily, I work on MacBooks. I do not work on people. Don't get me wrong, it's still better than the one where Paul Daniels ripped like 13 pieces off the board all at once. That's a moment that we will never forget. I have to make what he said during that video one of the donation ringtones. Because we have, ah my gosh, but we also have, oh, sweet mercy. I really got to get to work on that, because I keep promising I'm going to do it, and I keep forgetting and screwing up. Okay, from far away, a little bit of preheat. Soldering a QFN is much easier than this if your nervous system listens to you. Mine mostly doesn't. It just kind of laughs at me. Like, oh, you want to fix something? Well, ha. Kind of like the diode on a PP342_G3 out input circuit on an 8203437 or 820000165. It says ha. Just kind of laughs at you. Just kind of laughs at you. Are there any opportunities for Latino boys in the repair business? There are opportunities for people of all demographics in the repair industry, unless you have a profile picture of yourself without a shirt on. That's pretty much the only circumstance under which there's no opportunity for you. So, unfortunately, I don't think I can help you, because I believe you have an avatar picture of yourself on YouTube with your shirt off. So I actually had a friend on Facebook that he had a very clear model a policy where if you had your shirt off in your profile picture, he unfriended you. He just didn't want to see dudes in his profile with their shirts off, so he would unfriend everybody that had their Facebook profile photo be a picture of them with their shirt off. It was like it was a basic policy for him. And I wound up adopting the policy as well. Like, you meet someone in class, they add you on Facebook, and then the next day, just them with their shirt off, just like weird. Just weird. It's like, bro, I don't want to know you like that. Anyway. Okay, so now I'm going to be curious. Actually, one sec. Can move that over a little bit. Let's see how this turns on. Info Squad is the name of a channel of God, huh? That's my policy with females, says Dr. Normal in New York. It's always been my policy with... It's been my policy with social media for a while now. I'm confident there's probably a place. If you were to go to Vegas, I'm sure... Or like Times Square. Like shirtless micro solderer. There's probably a niche for that. I wouldn't be surprised if there's a niche for that. Sure, topless micro soldering. Okay. We're gonna redo that from scratch because that was shit. My hand is a little bit more calm right now. So I would like to do this to a standard of quality that I believe is better, more fitting. One moment. There we go. Hand is happier. You'll see it's just going to kind of flow into place naturally. And we want it to be flat on the board, so in a moment I'm going to tap it. Not again. Seriously? What the flying mother... Right. So it push down. After it's flowed into place where it should be, I want it to be flat on the board. So I just push, and wherever it was supposed to be soldered, whatever the perfect position was, we will already have, because it would have been dragged into there by surface tension. Push down, wait for it to dry, grab out the excess solder on the sides. Now this will turn on. Hand, pay attention to brain. Actually, don't pay attention to brain, because brain is good. Yes. You do what I say. Okay. We give this a second to cool off. And once it has cooled off, via the rapid cool technology system, we will see if it turns on, and then after that we're going to have to see if it's brain dead or not. Lewis be like Homer, think unsexy thoughts, think unsexy thoughts. I don't know how unsexy thoughts are going to help me right now. This is odd. I put my framework laptop, I folded it, and it's warm. Why are you warm? Did you ever go... I don't think you went to sleep. That's weird. Okay. I'm going to install my drivers on this thing. Might as well get started with using driver pack while I'm waiting. Okay. Okay, driver pack. I'm going to copy driver pack onto this. This should be, at this point, this should have cooled off enough that I can see if it works. We are going to plug this in. All right. Let's see what we get. Okay, 20 volts. Give me 20 volts and more than 20 milliamps. Okay, now we're getting 800 milliamps. We're getting 800. So that tells me that this is turning on, that we have potentially not dead CPU. Now I don't want to keep it without the heatsink on for an extended period of time. Obviously, we need to redo the thermal paste because I'm not gonna leave this with the shitty Apple thermal paste on it since we did the effort to take it apart. All I want to do is just get it plugged in enough so that I can see if we get a logo on the screen and it turning on. So I will do that with the crappy stock thermal paste, and we'll see what we get on the screen. I have a feeling that this is going to boot, and I have a feeling that once this boots, you're actually going to see it with an Apple logo and everything working. And this really just kind of demonstrates how the importance of not just replacing all of the components in the buck converter rather than just one, and B, the importance of when you're running voltage through the board for the short, not just going with the highest possible voltage. That's not how this should ever work. You're not just going to put the highest possible voltage in there. You're not going to just run in there with the highest voltage that you're allowed to put in that rail, because if you have a CPU MOSFET shorted, you'll wind up sending 12 volts directly to your CPU. And that's no good. And now, admittedly, I didn't know that was going to be the problem on this one. I was just explaining this all the way through, and I'm glad that I wound up explaining that before I did it, so that you understand, because this was a perfect example of that particular case. There are individuals that will see that's a 5-volt rail, that's a 3-volt rail. I'm just going to shove 3 volts into it because I'm allowed. That'll make the component get hotter. Sometimes people get impatient when they can't find where the short is and they want to send more voltage into it. The problem is, what if that's the power for the RAM? What if this, there are some RAM rails that are 0.75 volts. That wouldn't be very good at all. Okay, so we cleaned off the desk. I don't want to get anything on the customer's, any flux or residual chips on the customer device. So I clean that pad up regularly. So what I'm going to do is I'm going to plug this in. We're going to plug this in, and we're going to see what we get on the screen, if we get anything on the screen, and if it's booting. I just hope that it's not just, 900 milliamps and dead. I want to see that this is actually, what I'm looking for here, actually working. So let me just click the heatsink into place. I'll hold the heatsink on with my thumb for the time being. Not going to reassemble the whole thing until I see that it actually works. Just put this down while I attach the screen. Okay, just going to situate this into place. All I really need to be plugged in here is the charge port and the screen. Everything else is optional. It's just like a dessert. Not essential, as Andrew Cuomo would say. I don't know what he says anymore, because he's not the governor. I guess he's just enjoying his $4 or $5 million book deal. Can you believe that schmuck gets a book deal? I would like a $5 million book deal. I'd settle for a $100,000 book deal. I wonder if I could offer that to my landlord. Instead of the back rent, I will give you the rights to a book that I write about myself. What do you say? I'm pretty sure they'd want the back rent. Pretty sure they'd give me a stern go F yourself if I tried that shit. But if you don't ask, you never know. If you don't ask, you won't receive. Okay, we're taking 600 milliamps. I dropped that little piece of sticky plastic that goes over the battery. And I'm OCDing about wanting to pick it up right now, but I want to see if this boots first. But I want to pick that up. I got to see if this boots first. But I want to pick it up. All right, 622 milliamps. Come on, 700 milliamps, 600 milliamps. Show me some love. Show me some love. Don't be a dead CPU. Come on. Give me an Apple logo. Just getting warm. Alright, CPU is mildly warm. It's doing something. I'll give it a minute. See if anything happens here. Actually, I think that this may not have much hope, because this is taking a steady 645 milliamps. The last thing you ever want to see from a board with a working CPU is that it's taking a steady load. Like as it's booting, you should see the amperage use jumping up and down and up and down and up and down, because you got all these different transistors that are turning on and turning off and turning on and turning off. A board that takes like a very, very steady, when not charging a battery and booting up, like a very steady 650 milliamps or steady 500 milliamps without moving around, that's usually not a sign of anything good. Yeah. Now, if water did get in through the side, I am curious if perhaps the issue here is not with their board, but with their screen. I am open to the idea that their screen may be bad as well, so I'm going to grab another screen. I just got to find out where the spare screens are over here, because it's very possible. It's also just possible that I'm screwed. Anyway, I'll give it another chance to boot while I'm looking for another screen, but I have a feeling that this is going to wind up being a dead CPU. We did what we could, but it got a 12-volt punch to the face, and the 12-volt punch to the face unfortunately may have knocked it out for good, at which point this may go into the Paul queue. Yeah, I know, A1707 normal power is 1.7. I had wishful thinking, Anel. I had wishful thinking. Yeah, this is not normal. Yeah, and it's also it's dragging. It's drawing a steady state 640. Yeah, this is not going to be another. Anel's right. This isn't going to be a. This is not going to be something that. It's not going to be just a bad screen. This is going to be a bad CPU. Yeah, CPU did not like getting 12 volts to the face. Oh well. Oh well. I'll give this to Paul to give a look over tomorrow. We'll see if I was correct in my findings. Maybe I missed something. I sincerely doubt that I did miss something. I'll give it a one quick look through before I give up. Yeah, this is not even worth getting a new screen for, because it's taking 640 milliamps static. It should be taking 1.5 amps on the open and then moving around a lot. And it's not doing any moving around at all. It's just staying steady there. A CPU should not act like a purely resistive load when it's thinking. It should be kind of constantly jumping up and down a little bit. Oh, that's so sad. That's so sad. So sad. So sad. Poor MacBook. Poor MacBook. Remember that area around here where I flicked away a little solder blob earlier? I think it was like around here. Might as well be worth take a look for what that is. This is a sad board repair. I don't like the board repairs that are sad, but this is a sad board repair. Okay, that's power for the SSD. So that, I mean, granted, obviously, I don't want my SSD to be dead because it's soldered on here, so that would make it useless. But that's not our problem. The problem is that it's not even posting. Hi. V-core in this machine is 1.5 volts, so well, any of those other transistors happen to be liquid damaged on the edge of the board. I don't see any liquid damage over here. I don't see any liquid damage over here. And that's flux, that's not liquid damage. No liquid damage on any of those other ones. So what I would guess at this point is that if you have enough damage that there was actually a hole put in the chip that makes V-core. Not just, a little bit of water that wound up killing it, but enough damage that you actually have a bump in the chip that most likely on its way out, it did something like that to the CPU. This board may be fixable by replacing the CPU. But once you're at the point of replacing a quad-core or a 6-core CPU in a laptop that is not socketed, you are at the point of being beyond economically viable repair if you are not interested in the data. And this board, unlike the newer ones, has a lifeboat port on it. So if you want to get the data off of it, we can use this tool. It's not a tool that Apple allows us to have, but luckily someone leaked them on eBay a few years ago, and we bought a couple of them here at the store so that we could get people's data off when that happens. It's not impossible to replace the CPU. It's just you need to find the CPU off a donor board because you can't buy solderable CPUs like this on Newegg or any of those types of vendors. So you would need to take it off of a donor board and pray that it works. Or there are people that sell them that claim that they're new. Oh, the naive people who actually believe that. And you have to go, and then when you replace it, if it doesn't work, you don't know if it's not working because of the donor CPU that you took off of your donor board, or is it not working because there's something else wrong with your board. And then it winds up becoming a bit of a rabbit hole to hell that tends to not be economically viable for the customer, the repair shop, for the purposes of this type of repair. But replacing the CPU is definitely an option on something like this, and I've done videos replacing large BGA chips like PCHs and GPUs in the past. It's not impossible. If you want to go down that rabbit hole, you can. But unfortunately, this doesn't work. I did say that I wasn't going to get food until I fixed the MacBook, and unfortunately I'm going to be breaking my promise as I am quite hungry at this point in time. So I am going to go get myself some lunch. That's it for today. And as always, I hope you learned something. I'll see you all in the next video.